Let's have a look at number 7 in the lecture examples. Number 7 asks how many atoms of aluminum are there in 0.750 moles of aluminum. So it gives us moles, 0.75 moles, and then it asks for atoms. So we're going to multiply that by a conversion factor where atoms is on the top and moles are on the bottom. And let's see, the only equivalency I know is that 1 mole is equal to 6.02 times 10 to the 23rd atoms. So moles will divide away, 0.75, so 3/4 of a mole would be how many atoms? 0.75 times 6.02 times 10 to the 23rd. Calculator says 4.515 times 10 to the 23rd. In terms of sig figs, this number has 2 significant figures. This number, 6.02, 3 significant figures. And so that means in my answer, I get to keep 2 significant figures. So we're going to keep the 4 and the 0.5. So we would report that as 4.5 times 10 to the 23rd atoms. The follow-up question to that, number 8. Number 8 asks how many molecules of methane. Oh, weird. Oh, all right, that's terrible. Molecules of methane. So that's what we're looking for. Molecules of with methane, which is CH4, in 4.5 moles. 4.5 moles times. Now before we said that there were 6.02 times 10 to the 23rd atoms in 1 mole because we were talking about aluminum, which is an element. Here we're talking about methane, which is a covalent compound. It is molecular. It is comprised of a carbon bonded to 4 hydrogens. And so in 1 mole of methane, there would be 6.02 times 10 to the 23rd molecules of CH4. So it's still going to be 1 mole of CH4 is equivalent to 6.02 times 10 to the 23rd molecules of CH4. Or of any covalent compound. 4.5 times 6.02 times 10 to the 23rd divided by 1, which is irrelevant. And that comes out to be, so the calculator says 2.709 times 10 to the 24th. Based on our initial information, 4.5 moles, we're going to need to round this to 2 significant figures, and so we would report it as 2.7 times 10 to the 24th power molecules of methane in 4.5 moles of methane.